Hi, I'm Larry Puckett, the DCC guy. Today we're going to talk about a subject that makes a lot of people nervous when they initially hear about it, and that is programming decoders. And no, you don't have to learn any computer coding or anything like that in order to do it. And I'm going to show you how to program 8, 10 basic CVs that will probably cover 90% of your needs as far as programming. And I'm going to show you how simple it is to do. So stick around for the video and we'll get started. Hit that little red subscribe button, and when the little bell comes up, click on it and click all. Now, when I talk about programming decoders, I'm not talking about anything complicated involving writing computer code or anything like that. It is very, very simple and straightforward. And if you have ever set up a remote control for your TV or stereo or anything else and changed various settings for the sound and the contrast and the color and all of that, then that's about as complicated as it gets when it comes to programming decoders, because that's what you're doing. You're changing the settings, the basic settings that control how your decoder responds to your commands from your throttle. So let's run through what I consider the basic CVs, and by CV I mean a configuration variable, and that's what CV means. And then they just numbered them. CV1, 2, 3, 4, 5, 6, etc. And there can be hundreds, if not thousands of them in some of the more complex sound decoders. But for most of what you're going to be doing, there's only about 8 or 10 different ones that you're ever really going to use. So let's go ahead and I'll bring you in here closer and I'll show you how you can make these very simple programming changes to the CVs using a power cab. So come on in here close. Okay, what I've got here, as I said, I've got my power cab, and we'll be using this SW1 switcher made by Walthers for the programming, and I'm pretty sure it's got a Soundtracks decoder in it. And I'll show you how we can find that out here in a minute. Okay, let's get started with CV number 1. And CV1 is the 2-digit address. And the default value that is put in all decoders at the factory is 03. And the reason for that is because the NMRA has set that as the default value. And the reason is anytime you buy a new locomotive or install a new decoder in a locomotive, you know right off that it will respond to address 03. And you can put it on your track and go ahead and operate it, and then you can program it. And if you're programming on the main, you can use address 03 to do that. And you can change that to any 2-digit address. It's called a 2-digit address because it uses hexadecimal values. And it can go up to a value of 127 as a result. But for the most part, we're talking about 2-digit addresses. What I'm going to do here then is show you how to get access to that. So I just go in here and select my programming here. And when that comes up, I'm going to hit 4 because that gets me right to the programming track. And then hit enter to use the programming. And I'm going to hit 1 for standard programming. Now it's going to say wait because it's reading the decoder. Okay, it tells me that the manufacturer is 141. And I'll tell you how it knows that in a minute. But 141 is a Soundtracks decoder because the NMRA has assigned each DCC manufacturer an individual code. And 141 is what Soundtracks has. So we know right off that it's a Soundtracks decoder. And that, by the way, is in CV8. And we'll show you that in a minute again. Now, let's go on. The next thing, it tells me that decoder version is 70, actually 7.0. So if you need to find out how to program your decoder, any information about it, you can go to the Soundtracks website and look up information on decoder version 7.0, or at least tell the tech support guy there that that's what your decoder is. Let's move on. And by the way, that comes out of CV7. So we've already read CVs 7 and 8, but we'll do that again in a minute. Okay, set up address. Let's say 1. We're going to set up the address. Okay, so again, it's telling me short address 011. So I could change that, but let's leave it as it is. And the reason I used 11 in this case is this is locomotive 2011. So it's easy to keep track of your short addresses that way. And if you need to, you can use either the short address 11 or the long address 2011. Okay, let's go on. Activate this address. And this is a quick way to decide whether you want to use the short or the long address. I'm going to skip that and use 2011. Now it's going to look up the long address. So you can see right there it says 2011. So it's telling me that the long address is 2011. We'll talk about this later, but that comes out of CVs 17 and 18. Because it's a 4-digit address, it takes 2 CVs to program it. Okay, skip on to that. And activate this. Let's hit 1, and that will set it up as the address. Let's go ahead and skip out of this now and get to CV programming. So it's asking me to enter a number, and I'm going to hit 1 again just to show you. And it will come up and it will say address is number 11. So we'll go with that. And you could change that just by entering whatever value you want and program it. Okay, let's see what CV2 is. Now I'll tell you, CV2 is your starting voltage for your motor. And you can control how much voltage the motor gets. And that comes in very handy because locomotives can differ by the gear ratio and the gearing and how friction-free that gearing is, as well as the motor, because some motors start at a much lower voltage than others. So you can fine-tune the performance of your locomotive by changing the starting voltage. Now you can see it's already come up and it's saying 0, 0. So I've got it set at 0 for this locomotive. I don't need anything. You could crank this up and go up in increments of 1 to increase the voltage that initially is sent to that locomotive motor at speed step 1. So if your motor just sits there and hums when you start opening up the throttle and you'd like for it to start right away moving, then you can increase this value and that will do it. Okay, so let's get on past 2. Let's look at CV3. Now, what is CV3? CV3 is your momentum, and it's your forward momentum. So when you first start up the locomotive, you can have it so that it immediately responds to the throttle, or it slowly increases in speed. So it mimics what a real locomotive looks like when it's pulling a load, because generally they don't really take off instantly. They slowly pull up the slack in the cars, and then they start moving and pick up speed. And this allows you to mimic that performance. So I've got it set for 0 because it's a switcher, and I want it to be able to move cars around quickly in a yard or an industry, something like that. For some locomotives, like a passenger locomotive that does start up fairly quickly, you would want this to be a very low value. But for a freight locomotive that's going to be pulling a lot of cars, you could set this value up a little higher. And you can fine-tune that and get it to the point where you decide what you like. Okay, so I'm going to leave it set to 0. Now the next one, let's go to number 4, CV4. Bring that up. Okay, it's set to a value of 8. Now CV4 is the opposite of CV3. It's the deceleration momentum. So if you've got a locomotive with a string of cars behind it, and you start slowing down, kicking out the throttle, it isn't going to stop instantly because it's got a certain amount of momentum because of the weight and movement of the cars behind it pushing it and its own weight. So it's going to slow down slowly. And you can mimic that type of behavior with this deceleration rate or momentum. So I've got it set for 8, and that's a value I like in this case for the switcher. And again, you can play with that for your locomotives and get a feeling for what you like for your locomotives. Okay, let's go ahead. I'm going to leave that at 8 because I like it that way. Okay, let's look at, we've done 4, let's go to 5. Okay, CV5. Now CV5 is the maximum voltage that is applied to the motor. So it's sort of like the top speed that you can get out of here. And you can control that. You can change this, lower the value. I've got it here set for 100 as opposed to 255. So I don't want this locomotive to be able to go flying down the track. I want it to be a nice slow speed performer. Okay, so this is also part of what's called your 3-speed step speed curve. And CV2 is the low end of the speed curve, okay? And CV5 is the top end of the speed curve. So if you wanted a linear response, you could have a value of 0 and 2 and a value of 100 or 255, any value, in 5, and it's going to be a straight acceleration line between those 2 points. That's one way to do that. But there's something else in here. So you can use CV5 in order to control the top speed of a locomotive and control the top end of a 3-step speed curve. So let's look at the next one, CV6. I'm going to keep this at 100 because I like this locomotive to go fairly slow most of the time. Okay, let's go to CV6. Okay, CV6 is 62. So that's a little bit higher than half of CV5. And the reason for that, CV6 is the midpoint of that 3-speed step curve. I know, it doesn't make any sense to me either. Why did they make 5 the top and 6 the middle? It would seem like it should be the other way, 5 the middle and 6 the top. But that's the way they did it. I can't change it. I wasn't on the committee. Okay, at any rate, so I've got it set to a value of 62, which is a little bit more than 50% of 100. So that means that the locomotive is going to speed up a little faster than it would on a straight line acceleration, and then it's going to slow down a little bit or decrease the acceleration rate going from 62 to 100. So that gives you a little bit of an inflection point in your speed curve as you're accelerating from 0 to 100. If you wanted a perfect straight line through it, you would set CV2 to 0, CV5 to 100, and CV6 to 50, okay? And that would give you a perfect linear speed curve. If you wanted it to accelerate slower, you could set this for, say, 30. It would accelerate slower up to about halfway, and then it's going to start increasing in its acceleration to get up to 100. So that's basically how it works. Okay, let's go ahead and move on. CV7 is 70. As I told you earlier, when the power cab was reading the manufacturer information, that it came up with a value of 7.0 for the version. And this is where it comes from, CV7. So it was actually reading CV7 for you and coming up with that value. Okay, let's go ahead and go on to CV8. And by the way, you cannot change these two. They're set at the factory and you can't write them. Okay, so let's look at number 8. There it is, right there. Okay, CV8, 141. Again, that's the manufacturer's ID, soundtracks. And as I told you earlier, that is set by the NMRA, and it was reading that value to get that. Now, the interesting thing about this is there's another way that you can use CV8. Now, in most cases now, most decoders will respond to a value of 8 being entered here. So if I entered 8 in this and hit return, it's going to change every CV in this decoder and set them back to the factory default values. And that can come in very handy if you screw something up at some point and you need to get back to a starting point. It allows you to reset a decoder back to the factory default settings, and that can be very useful. Sometimes the locomotive decoder will stop responding for various reasons. Maybe it got a voltage surge on the track, maybe something else happened, but it will stop responding. And very often, if you put it on the programming track and send a value of 8 to CV8, it will do a factory reset, and it will start working again without any problem. So that's one great way that you can use CV8. Okay, so we've gotten a lot done at this point. Now, what else could we look at? Well, I showed you the long address earlier. And the long address takes two different CVs, so let's look at them. So the first one is 17. So let's see what that comes up. 199. Now, it gets complicated at this point. That's why when we were doing the standard programming up front, it was very easy to let the power cab read the actual address, because it will read CV 17 and 18 and give you the actual 4-digit address. It deals with the most significant digits and which significant digits are programmed into CV 17 and 18. So for that reason, I think you're going to want to use the built-in capability of the power cab to read the long address for you. And you can use that to program it. You don't have to figure out what goes into 17. And let's look at CV 18. I'll show you that as well. See, it comes up 219. Now remember, the value in this decoder is 2011, so that's seemingly meaningless. But there is a way to convert that back to something that you could read and understand. But right now I'll tell you that it can be complicated to actually program CV 17 and 18. So you're much better off using that standard programming capability that's built into the power cab. And just about every other DCC system I'm aware of does that for you when they're reading and writing the long address. You do not have to try to figure out what the least significant digits are and the most significant digits are and how to enter them into CV 17 and 18. Well, I hope that answered your questions about programming decoders, because it is fairly simple and straightforward. And in the next video, we'll get into a little bit more complicated subject, and that is CV29, the master variable, and I'll show you how to simplify that one and make it easy to program as well. And then once we get those out of the way, then we'll start getting into the stuff that's a little bit more complicated. And that will involve turning on my computer and using Decoder Pro. And that's one way to make it very easy. So come on back for the next video. And in the meantime, have a great weekend and a great week. Bye now.